Hello and welcome, or welcome back to the GWSDAT tutorial series. Today we're going to be covering time series. This video specifically covers the time series plots that GWSDAT produces for each well in Solute. To find the time series plots, click here next to spatial plot. Displayed will be a time series plot, i.e. a concentration of a given solute over a time range for a specified location. The actual data points are represented by black dots. If our dataset contained any substituted and non-detect values, they would be displayed by orange dots, and if our dataset contained any NAPL substituted values, they would be shown by red dots. The solid blue line displays the estimate of the mean trend level at a particular point in time. The upper and lower dashed lines depict a 95% confidence interval around this estimate, which can be interpreted as it is highly likely that the actual mean lies within this region. Under Select Monitoring Well, we can select which wells we want to use. More than one well can be selected as a version 3.3, and each is displayed side by side. Same can be done with the substances. If you're using an earlier version than 3.3, only one well and substance can be chosen at a time. The solute concentration unit radial group allows you to change the units between nanograms per litre, micrograms per litre, and milligrams per litre. And the display threshold checkbox displays the threshold value used to color code the trend and threshold indicator plot. On the bottom right of the plot, you can adjust the date range for the time series plots. This will also update the displayed date at the top of the page here. The Generate Well Report button produces a plot similar to the well report from video 4.6, which we linked in the description, but additionally allows the overlay of groundwater level and NAPL thickness on each plot, with the additional axis on the right-hand side of the plot. This will be covered later in the video. Now looking at the time series plot options, Conc Trend Smoother displays the estimate trend in the solute concentration with a non-parametric smoother. Essentially, it toggles the blue mean and confidence interval lines discussed earlier in the video. Conc Linear Trend Fit displays the traditional linear time series trend estimate. It will show a model of similar statistical sense to the blue lines, except that it is linear and will not fluctuate with the data. It is the equivalent to fitting an exponential decay growth model on a linear scale. The statistical significance of this can be seen through the Mann-Kendall Test, as seen by the Mann-Kendall p-value and the estimated solute concentration half-life displayed here. Note that the individual well half-life should not be used to estimate the plume half-life. If the Mann-Kendall p-value is below 0.05, then the estimated trend is deemed statistically significantly different from zero, implying that there is a trend. Conversely, if the p-value is above 0.05, like it is here, then there is not enough evidence to suggest a trend. The Mann-Kendall test returns this linear trend, which can ignore curved data, as we can see here, as the blue line follows around this way, but the green line for the linear fit is quite different. Show Legend displays a legend at the top of the graph, allowing the user to read the graph more simply, as it tells you what each of the colors and lines and points mean. Scale Conc to data will change the scale of the axis. By default, the time series plot x-axis is scaled such that it spans the sampling dates of all data, and the y-axis spans the current data concentrations and the user-specified trend threshold limit, covered in video 4.5. By checking this box, the x and y-axes are scaled to the span of the current combination of the well and solute concentration data only. Log Conc scale toggles whether the y-axis is scaled linearly or logarithmically. Finally, overlay groundwater levels lets the user overlay the corresponding groundwater level measurement on the time series plot. The scale for this is on the right-hand side. The function is useful for assessing the correlations between groundwater levels and solute concentrations. If your dataset does not include groundwater values, then this option is not displayed. Similarly to this, here we don't have any NAPL values. However, if we did have NAPL thickness values, we'd have another option here to overlay NAPL thicknesses, which would let the user overlay NAPL thickness measurements on the time plot with the axis on the right-hand side, which would be useful for assessing correlations between NAPL thickness and solute concentrations. Thank you for watching the video. If you enjoyed, please like and subscribe. And if you have any questions or any feedback to give, there'll be a link to a feedback form in the description of the video.